In this video, I'm going to introduce a statistical test referred to as the t-test, and this is one of the many statistical tests that are carried out for purposes of hypothesis testing. So what is the t-test? The t-test is a statistical procedure that's based on something called the student's t-distribution, and I'll describe who student is here shortly. And the t-test is used to compare a collection of numbers, so a grouping of numbers coming from one group and only one group, and comparing the group average against a test statistic. And so the important thing to understand here is that the one sample t-test is named according to the fact that we only have one collection of data, one set of numbers that are not divided into more groups. It constitutes just one group. But many research applications involve two different, unique, discrete groups of individuals, businesses, or whatever we wish to investigate as two collections of different numbers. And when we want to statistically compare between the two groups for significant differences, we would use something called an independent t-test. If we have two measurements from the same grouping of people, but we have two different sets of numbers, we would carry out what's called a paired samples t-test. And in this unit, we will progressively work through three different examples that are applicable to the one sample t-test, the independent samples t-test, and the paired samples t-test. To contrast that with a statistical procedure called the z-test, the z-test is used only when the researchers know the population standard deviation. In most research applications, researchers do not have access to population level data, and of course, if that's the case, researchers would not know what the population standard deviation is, and that would require the use of the t-test. It's important to note that the z-test only is based on one and only one distribution of data, and that is the normal distribution. However, there are a whole family of, or many, t-distributions, and each individual t-distribution of data depends on the sample size, and we'll look at some of those examples here in this unit. Just a couple of more points on the t-test versus the z-test. The one sample z-test is carried out to determine if a sample from a population is representative of that population. And that can only be carried out if the researchers have information on the population standard deviation. So this is the equation that we won't be using in this particular video or in this unit, but the z-test assesses the difference between a sample average and a population average divided by the standard error of the mean. And to get the standard error of the mean for the population, one would have to know the population standard deviation. And if researchers have that, then the one sample z-test would be applicable. However, in most situations, the population standard deviation is not known. But the one sample t-test has the same objective as the one sample z-test, in that we would carry out a one sample t-test to determine if a sample is representative of the population. This carries a little bit more limitations than the z-test, because the population standard deviation is not known, and that occurs in many different research applications. But you'll see that the one sample t-test is based on the calculation of a t-statistic, and to calculate the t t-statistic, we would have to know the sample average, and because it's a one sample t-test, we only have one sample. We subtract that from the, or we subtract the population average, and we'll speak to this in the next video, divided by the standard error of the mean for the sample. We have to calculate it for the sample because we don't know the population standard deviation. So this is the fundamental equation used for the one sample t-test. Now, to understand the genesis of the t-test, the t-test was developed by a scientist by the name of William Gossett, pictured here on the right hand side. And William Gossett was a chemist and a mathematician who, upon graduation in Dublin, got a job working for the Guinness Brewing Company. And his job was in the area of quality control. So he was carrying out experiments inside the Guinness Company to determine ways to produce better tasting beer. But he had very limited resources to work with. And so he had different varieties of barley, but very, very small samples of barley to work with. And the mathematics at the time were not sufficient to produce results based upon very small samples. And so Mr. Gossett developed and basically invented some new mathematics and new statistics, and developed a family of t-distributions. Now, company policy at the time precluded employees from publishing any work-related information using their name. And so in order to provide the mathematics to the scientific community, William Gossett published his equations and published his work on developing the t-test, not under his name, but he used a pseudonym, and the paper was published by Student. And so since then, the t-test is often referred to as the Student's t-test, named after the author of the paper. So this ends our first video on the t-test.